Okay, so I am no longer gonna go into part one. I'm gonna go to part two real quick and do the fluid mechanics because most of my classes this quarter is gonna be related to that. But first of all, I'm just gonna recap everything I have finished because I finally have a decent math section, which means I'm going to the physics section, and I've been doing that because I don't like the next few parts where the next few sections is parts that are really, what's the word, annoying to do. For example, Green's theorem is doubly annoying because we're dealing with closed loops with non-conservative fields, and you just basically do a lot of this everywhere. It's kind of painful. And then there's Stokes theorem, which is also kind of painful. But I have finished up the this section where I found a mistake here where there's a minus over here, which I fixed. I put a plus instead of a minus, which is why the numbers are a little different. And we finally did flux in two dimension, which is more useful than one dimension usually. Not to say that one dimensional has no use. It definitely probably does. I just never used it personally, but it probably has uniform like z. When the z doesn't matter, you could use one d thing, and everything is constantly moving in one direction, and you can use it. Um, yeah. Anyway, surface area. Oh yeah, the last surface area is this thing, which there's a shorter way to say it, but this is basically the general formula I just put in there, because you usually use x and y, and therefore that's the most useful one. All right, and then we go into the most basic of basics of Green's theorem. Oh, sorry, I've not actually done it, finished it. I just started it, and then I went to differential calculus because differential calculus is actually pretty useful for my current classes. So I just did a few of them. I just fixed up the slope fields. Very fun to do these slope fields. Obviously, this visualization is kind of wrong where the end is not showing up, but it's basically a circle. Um, it kind of works. The code that I put up kind of works. It kind of breaks. I probably should write down that it broke down near the zero axis over here because it did break down over here. I don't know why. It should work. Honestly, I have no idea. And then I have to finish up all of the yes, because I have to prove this. I was gonna prove this later, but I did realize I did explain it later, but explaining it now might be the easiest method. So I'll explain it now later, but not now. We're done for now. Now, physics mechanic, I have revamped it to make it cleaner. It is much better than before. It is done. Pretty much done. I might add more here and there. Um, Yes. Uh, and then we did put the density section over here, pretty much very fast density section, and then we immediately go into kinetic equations, which has a few proofs here. Uh, and then the proofs are really not important. You can go back and look at them. Um, it kind of explains what happens when a is constant, and if you have different speed, and if you have one speed here, the different speed later on, the average velocity, which I'm not sure if I talked about that, so I might have to add that. But the physics is more important usually than the mathematics because physics is what we use with math. So I would say that physics is more important for an engineer, but that's my personal opinion. So yes. So I'll probably do that final initial velocity. Um, we curl, and then luckily because I have done it so that we did math first, I can do the higher version of it. Usually, you just talked about the 2D version, which is what your class will talk about, which my class talked about. Even then, they don't really say it like this. They just say it like it doesn't matter where you move it. The vector field doesn't matter. The whole thing is a show. Therefore, the integral doesn't matter, and blah 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 blah. But I could just plug in the mathematical real version of it, the proper one, and not matter because we pretty much finished up the math section in this book. So we can just do the. This might need revamping, but it's pretty okay. This is dynamic in newtons, yes, it's fine. Yeah, that's force, and then we keep on going down. So it's yeah, I might need to revamp that later on. I might see to change it. And then circular motion, because for some reason they love to put this question in. It makes sense for aerospace that I would want this also, but in reality, I think you would want to use the Kepler version of it because that's the only one I use in actual classes in the that department. So really not useful. I don't know. Engineering department doesn't use the box. They use the polar. In my experience, I don't know. It might be different later on. It might be useful. And then but as I only I forgot I did this. This was the some kind of work integral, which is a line integral. Um, Pretty fun, isn't it? Maybe I should explain it better because the line integral. I mean, it works. It does explain what I'm doing. Um, it is correct also, so it's not a problem. Yeah. I'm just thinking right now, did I do the line integral wrong in that over there? Because for some reason I think I did it wrong. Wait, huh. I'm curious because this should be exactly the same as what I did in the over here section over here, and it doesn't seem to be the case. What is going on? When I did a line integral, I took the derivative first and then the dt, and that's how I did the integral. But over there, it seems to be more of the displacement in the thing. So I know the physics definition is right, and I also know the math definition is right. So there must be something I'm missing. I'm missing something. I just don't know what I'm missing. It's conserved. Yes, it's conserved. It doesn't matter which path I take. I could take the path of the motion. Yeah. Is that what I did? Hmm. Let me move this real quick over there just to see what the hell is the difference between that and this. Um, because it should be exactly the same methodology um, to get work. And if I can't figure out what's different, then one of them is completely wrong. So what I did was I had a R and T. R and T, yes. There's a final R. Oh, oh, the difference is that they have a final R and an initial R. Let me do a horizontal line. So over here, the method I use is that we have a R. Oh, this is a method of just getting the 2 points and defining the difference between each other in one direction and the other direction. It's the same exact thing. Just, huh? Okay. That means that I can do. I did not know this. This is something I have forgotten. Really. Um, So if I look at this to say 0 to 1, it's 0 over here initially, 1 over here. So we get, and let me insert a new equation real quick and do a left click over here. This would be, if I plug in 0, it would be 0 would be 1 comma 0, and then the other one would be 1. So 1 0 comma 1 is for the initial final. And according to that, it means if I took the force, which where the fuck is the force? Oh, force is this thing. Okay, so if I took the integral of this, let me go to decimals, which I'm definitely not using by hand. So go to int. Why doesn't it work? Oh, 0 to what was it again? Oh yeah, that's this is the section we're doing now. We're gonna finish up MA 101A in the next um 2 days because Thursday is when my class starts. It's not gonna be good. It's gonna be absolutely trash, in the organization department. But it's gonna be good enough. But I want to test this out. So it is 1 to 0 over here, right? Uh, and then we have plus int over here, and it's y direction over here. So that would be 0 to 1. Okay. So this looks like Green's theorem a little bit. Oh, is this accidentally doing Green's theorem? Kind of. It might actually be doing something similar. I never considered it, but it might be something similar to Green's theorem. But I am not sure because I know I know how. Here's the thing. Green's theorem is I know how to do it by doing steps, but you never really taught the real proof of it because the proof is too extravagant and too technical. They just do a watered down version of it, so I always get confused about Green's theorem and Divergence theorem. That's why I'm looking for those proofs, and I will find them eventually because I always do. It just takes a while, um, and then I have to cite them afterwards, so they're a pain in the ass to do. But I always do them, so they will. Oh, I see now. I see now. This is the relationship of the force is in x and y, while this is just having x x. So I get it now. Oh, the difference between this and this is that the x there's no y over here and there's no x over here. That's why this can be like this. It could be simply done. All right, I figured it out. All right, I figured it out. Let me just delete all this real quick. Actually, then doesn't that mean that I can do this and still be fine? I don't remember which one is dx and dy. I might be wrong. I am totally wrong on something. Function. So. Okay, I'm totally wrong about this. Um, well, that's my assumption is horrible. Let's just say that. Okay. So the reason this can happen, I totally forgot, is that the initial x and y is following that the x is only has x's and y only has y's. Um, even though I forgot to put j over here. Anyway, so I here's collisions, and then we finally go. I might need to change this. This looks goddamn awful. I am, but I don't have time right now, so we're just gonna just show it off, and then I'll fix it later. Um, and we reintroduce Jacobian matrix again because Jacobian matrix is all of momentum inertia really very important for that. Um, Not very important. It's actually quite useless after you just get the actual final answer. It's completely garbage because there's no reason for you to redefine something. Just use summation and with distance and just plug into a formula calculator and you're good. There's no reason for you to make your life hell for no reason. And then here's all the experience. And then I'm finally going to physics 2B. I cleaned up the title because I'm almost gonna be done by next year on this section. I'm pretty sure. Um, to tell you the truth, my book doesn't just cover things from here. It covers things more than that because uh, what happens is that they only teach you the basics, I believe, and then they don't go deeper on the proofs, at least in the introduction phase. So. Um, all of this information is pretty much not needed. A lot of these are not needed. I'm just putting them in for the sake of me understanding it because some of the explanation is not enough explanation in my personal opinion. Um, and then yeah, we go beyond here. And then that's all we have done. I moved the Physics MAE 30A and 30B and 11, I believe. We're gonna start. I think we're gonna move all of these to part two, which is over here, and I'm gonna work on this from now on for the next 2 days, basically, and hopefully we can finish as much as we can. We'll not care about the how it looks. We're just gonna speed. At least I'm gonna. I might not even cover it until later on, so we'll see how this turns out to be. And I'm pretty sure that's all I have completed.